Hello students, welcome back to physics. Today we're talking about energy transformations. This should be a quick video and some of the stuff you might know already. So this is maybe a review, but quick definitions and concepts. Energy transformation is when energy changes from one form to another. There are many forms of energy. We've mostly been focusing on two of them in this unit, but there are lots of others. And then the conservation of energy is the fact that energy is neither created nor destroyed. It's only transformed from one form into another, and no energy is lost. And that goes back to the beginnings of time, all the way back to the formation of the universe. Basically, all the energy was formed, and it's just been moving around, changing into different forms throughout all of time. So, as I mentioned, we've mostly focused on kinetic and gravitational potential energy. And so, one of your tasks for this topic is you're going to look at some other forms of energy. You're going to pick your three favorite out of the following list, which I'm going to show you in a moment, and you're going to do the following two things. So first of all, you're going to define the form of energy that you've picked out of, well, all three of them. And I'm going to provide some textbook pages that you can use to do that, or you can do research on your own. Excuse me. And the second thing is you're going to write an imagined scenario in which your forms of energy are being transformed into one another. And you have to do it for every combination of the three forms of energy that you pick. So for example, if you pick three forms of energy, A, B, and C, then you're going to write a scenario for how A can transform into B, and then another one for how B can transform into A, and A into C, C into A, B into C, and then C into B. An example of a scenario is for kinetic and gravitational energy, which you can't do because those aren't on the list. But if you're doing those two forms of energy, then you could just write something like this, just a one sentence thing. When a ball is dropped and speeds up, gravitational energy is converted into kinetic energy. So that's all I'm looking for. It's obviously going to be harder than that because you're dealing with other forms of energy that you haven't studied as much, but just do a little bit of research or do some imagining and creative thinking and see if you can write scenarios in which each of these forms of energy is transformed into the other. And these are the forms of energy that you can choose from: elastic energy, electrical energy, thermal energy, sound energy, nuclear energy, chemical energy, and radiant energy. So there are lots to choose from. You might want to do a little bit of reading before you choose, just because it might make the scenarios easier to choose certain forms. And yeah, that's it. So just try to get a sense for how energy transforms from one form to another. Okay, and then other than that, we're just going to do this example. You probably kind of already understand this from the lab that you did, in which you had to look at this, a similar sort of thing. But I'm just going to go through this quickly. So basically, we have a diver who is on the top of a diving board and is going to dive, obviously. And we're going to see how his energy changes over the course of the dive. So at first, his energy is entirely gravitational because he is not moving. He has no velocity. Therefore, his kinetic energy is zero. And it is given in the question that his total gravitational energy initially is 6.4 kilojoules, which means his total mechanical energy is 6.4 kilojoules as well. And the question is, what is his mass? Well, if all the energy is gravitational, then it's pretty easy to just sub these numbers into the gravitational potential energy formula. So put 9.8 in for G and 10 for H. And then by the way, just make a note that this is kilojoules, so we need to multiply it by 1,000 to convert it into joules, and then solve for M. So that's going to give you 65 kilograms. Oh, that's a mistake. Sorry, that should say 6,400, not 64,000. I remember making that mistake on my calculator and being confused. Okay. Next part of the example. So now let's say the diver is halfway down. So he is 5 meters below the diving board, also known as 5 meters above the water. And you can consider him to be a point rather than a long human body, but whatever. This is one of the simplifications we make in physics. So when the diver is halfway down, what is his velocity? Well, you could solve this question with kinematics, but you can solve it more easily with energy, with principles of energy. And this is a common thread with conservation of energy, is that a lot of this stuff can be solved with kinematics, but it's easier and simpler and faster and more efficient to solve it with energy. So the most basic thing to think about is that half of his energy has now been converted into kinetic energy because his height is half of the original height. And if you think about the gravitational potential energy formula, mgh, if you make this h value half of what it was before, while the m and g values are still the same, then the final answer is going to be half of the original final answer. And so half of the energy, which will be 3.2 kilojoules, will now be kinetic energy, and the other half will be gravitational potential energy. So half of the energy has been converted or transformed into kinetic energy, and then you can use the kinetic energy formula to solve for the velocity, because we know the energy and the mass, and so you can solve for velocity. So bring everything to one side, take the square root, and you get 31 meters per second. And then finally, at the moment just before the diver hits the water, how fast is he traveling? So at this point, his height will be 0 because he's just, centimeters above the water, and you can consider it to be essentially 0 centimeters above the water because it's really just the moment before he hits the water. And so therefore his gravitational energy is 0 because that's in the formula h equals 0. So all of the energy has been converted into kinetic energy. And because energy is neither created nor destroyed, he still has the same amount of total mechanical energy, which is 6.4 kilojoules. So you sub that into the formula and solve for V. And in this case, should that be 984? I feel like, oh, that's the number from before. That's another mistake. Sorry about that. This 984 should actually be double that, I want to say. Anyway, you can figure it out. The final answer is right. It's 44 meters per second is the right final answer. And what is the total mechanical energy for each of these scenarios? Maybe this is obvious, but it's the same. It's 6.4 kilojoules. You get there in different ways in each scenario. So initially it's all gravitational. In the middle, it's half and half. And finally, it's all kinetic. But regardless, you get the same answer for the total mechanical energy. And that's it. So try that task that I wrote before about energy transformations, and then a few questions from the textbook.